Hello, everybody. You are all welcome to the TEJS107 course. Given the number of weeks we have to complete the course outline, I've decided to start a series on some of the topics. And bearing appears to be the first topic. I'm doing a pre-recorded video. This will help us to be able to complete the course outline. I still remain your facilitator. My name is Manasseh. All right, so without further ado, let's get started with the concept on bearing. So one thing you have to always bear in mind when it comes to bearing is that bearings are special angles that are measured in the clockwise direction. And our reference point is always the north. So unlike what happens typically in trigonometry, if you want to measure any positive angle in trigonometry, what happens is that I have to face the positive x direction or eastward, and I'll move in the anti-clockwise direction. That's what happens when I'm measuring an angle in trigonometry. But bearing angles, on the other hand, are measured in the clockwise direction. So I want to find a bearing of Accra from Kumasi. So assuming this Kumasi and this Accra, bearing of Kumasi from or Accra from Kumasi, this Kumasi and this Accra. So bearing of Accra from Kumasi. So the important aspect is that you have to go to a starting point from Kumasi. So assuming this Kumasi, so that I'll have my cardinal point to help me know my direction. So once I indicate my cardinal point, I have to face north and I'll move in the clockwise direction. So this angle over here will give me the bearing of Accra from Kumasi. Now take note, bearing angles are always written in 3 digits. So for instance, I'm looking at the bearing of A from O, bearing of A from O. What happens is that once I have my cardinal point, I'll face my north and I'll move in the clockwise direction. So this angle over here will give me the bearing of A from O. So if this is 30 degrees, then the bearing of A from O will give me 60 degrees. Over here, you can see why 60 degrees, but when I'm writing it out, when I'm writing the bearing of A from O, I'll write 0, 6, 0 degrees. So likewise, I can find a bearing of B from O. I'll still have to face the north direction and move in the clockwise direction. So typically I'm moving, when I get here, it's a quadrant, so this is 90 degrees. Then I have to cover up to here. Now this is another quadrant which is also 90 degrees. So if here is 45, then the angle over here is also 45 degrees. So the bearing of B from O, from this angle over here, will be 90 plus 45. So I'll sum, and that'll give me my bearing of B from O. So 90 plus 45 should give us 125 degrees. So likewise, if I want to explore the bearing of C from O, once I'm here, I have to face north. I'll move in the clockwise direction. So 90, that's a quadrant, another quadrant, 90, giving us 180. Plus this angle over here. So if this is 42, then you agree with me that this angle will be 48 degrees. So 180 plus 48 degrees should give us the bearing of C from O. That's the measurement over here. Great. You can also explore the bearing of D from O. The same concepts, we have to face north and I have to move in the clockwise direction. So 90, 180, 270 plus this angle over here. So if this angle is indicated at 54, then you agree that this angle will be 36 degrees. So 270 plus 36, if you add, that should give us the bearing of D from O. Great. So I managed to write those angles that we explore over here. So you can pause this video and try to explore the bearing of X, W, X, Y, and Z from the starting point. So you can start thinking about the bearing of W from O. So you have face north and measure up to this line. So if this is 65, then you know that this angle will be 25. So the bearing of W from O will be 0 to 5 degrees. Because bearing, typically they are written in 3 digits. So if the angle is acute, which having 2 digits, you have to bring a preceding 0. So if you have 20, you have to bring a preceding 0, making 0 to. So if you have 25, I'll bring a preceding 0, making 0 to 5 degrees. So take time and explore the bearing of X from O. So you have to face north, move 90 plus this angle. So take note of this angle. Then if the entire quadrant is 90 degrees, you can find the remaining angle here. So 90 plus that should give us the bearing of X from O. You can start playing with this one and the one over here as well. Or with the reference point is O. So the bearing of Y from O. So you have to go clockwise, get another 90, then get the angle over here. The bearing of Z from O. Our reference point is O, so that's the center. Face north, move 90, another 90, another 90, then get an angle over here, then find the sum. That will give us the bearing. So I believe you are getting along with me. Wonderful. All right, so we have a typical question that we want to explore. So let me stop sharing so that I can pull my whiteboard. All right, so this is my whiteboard. I believe you can see my whiteboard. So we are to explore the bearing of A from B. From B, so our starting point is B. So let me pick my marker. So my starting point is B. Wonderful. So the bearing is given as 030. So that's 30 degrees. In the diagram, I indicate 30 degrees. But when I'm writing, I can write 030 degrees. So this is my north, as you can see. Now, it's not drawn to scale. So if this is 0 and up to here is 90 degrees, then you have to just imagine where to locate your 30 degrees. So because maybe half can be 45. So once not on the scale, you are okay to just use your eyes and make sure you can locate the accurate angle. So from my sketch, I can say that this angle over here will be my 30 degrees. So when I end, I have to indicate my endpoint. So that's the A. The bearing of A from B. So the from B is a starting point, and where our end is the A. Now we have to find the bearing of B from A. So I'll go to my starting point from A. I'll look north and I'll start moving clockwise until I reach a line that connects the B. So let's proceed. All right, so this measurement should give us a bearing of B from A. So 90 plus another 90 plus this angle over here, which we are yet to find. Now remember, this angle, this line, and this line are parallel lines. When I say parallel, it means that these two lines will continue moving, they will never meet. Now, this line connects these two parallel lines. So this line serves as a transversal line. So in that case, you realize that I have an angle here, and that's a Z shape. So this angle here, 30 degrees, will alternate with this angle here. So this implies that this angle here will be 30 degrees. All right, so it means that the bearing of B from A will 90 plus 90 plus 30. So that's 180 plus 30. So that should give us 210 degrees. Now this angle is already 3 digits, so you don't have to bring a preceding zero. So this is 3 digits already, so we'll leave it like this. So that's the bearing of B from A. Great, so let me stop sharing so I can go to my slide. All right, so I believe you are getting along smoothly with me. Yeah, so I also managed to pull this together over here. So together with the sketch I did and this one, I think it should be good. All right, so you can also pause the video and try this. Just pull your paper and your pencil and make sure you try the sketch. I can as well do it together with you. So we can do it together. But let me give you some few minutes to explore, then we can do it together. All right, so let me stop sharing so that I can pull my whiteboard. And I believe by now you've done with your sketch. So let's see if your sketch will go in tandem with my sketch. So if the bearing of x from y, so our starting point is y. That's our starting point. So I have my cardinal point nicely. Then I can, these starting points can be y. So that's 150 degrees. So I have to face north, move in a clockwise direction. So when I cover here, that's 90. So the question is 90 plus what will give you 150? So 90 plus which angle? So you realize that it's 60 degrees. So I've already covered 90. I need additional, this is also another 90, but I need only 60 degrees. So if someone on the scale, I'll make sure you locate it wisely. So I can have my, this is a bearing, 150 degrees. 150 degrees. But if you can choose not to write 150, just indicate the 60 degrees over here. That's the important thing. So this is 60 degrees. That's important. So now I can now indicate my endpoint as X. Wonderful. So we are now asked to find a bearing of Y from X. So from X. So that means that this is my starting point from X. I have to face north and move in the clockwise direction. So I'll keep moving, keep moving, keep moving. All right, so you have given me this already 90 plus 90 plus 90, giving us 270. Now this is the remaining angle we need so that we can get a bearing of Y from X. Now this line is going, this line also going, they are parallel lines, and this connecting them transversal line. So this is another Z angle, and those angles alternate, they are the same. So if here is 60, then the angle here should also be 60 degrees. So you can start thinking about the bearing of Y from X, that's 270 plus 60 degrees, then that should give you, and I believe we all managed to get that correct. Thumbs up if you managed to get that correct. So let me stop sharing so that I can return to my slide. All right, so gradually we are making progress. So we have that here nicely for you to compare with what you did. All right, so I just want to bring attention to one area that is very important. You know, it's not always that in bearing, the angles will be given in the form of the 3 digits. In some special cases too, the bearing angles or the angles begin in the form of direction, in the form that not a typical bearing angles in the form of direction. So maybe for instance, I can talk about a ship moves from point A to point B on a direction. So in this scenario, I'm not giving a bearing, but I'm giving you a specific direction based on a cardinal point. So for instance, I can talk about maybe this car moves from this point O to point P. Which direction is the car moving? So north, theta degrees east. So what this means is that the car is now theta degrees east of north. So assuming here is 20 degrees, you know, all here is north, but it depends on the angle. So when I write, let's say, north 30 degrees east, it means that if the car is here, the car is now 30 degrees east of north. So you can have 60 degrees east of north. So that is typical direction. So direction, the angle is always formed with the north line or the south line. So I can have another one here, and the angle should be formed with the north line. I can have another one here. The angle should be formed with the south line. So we can have always either the north or starting, and the east and the west should always end. So directions are angles that are either north, either east, I should say, or south of north or west. So if you see this angle here, assuming the angle here is 30 degrees, so I have south 30 degrees east. It means that maybe this car is now 30 degrees east of south, because all down is south, but it depends on the angle. So I can have 40 degrees east of south, 50 degrees east of south, 70 degrees east of south. So that's the direction. Always make sure that angles in direction always start with the south or north and end with east or west. So let's try to pick a practical example to demonstrate that. All right, so we have these two examples, and I'll pull my whiteboard too so that we could explore it. Now the question indicated that a boat sails 3 kilometers on a direction north 60 degrees west. How far west is a boat from the starting point? So just pause the video and try along with me. So let me stop sharing so I can pull my white board. All right, so let me claim what you did earlier on. All right, so let me have my cardinal point. So the boat sails, so this is my north, this direction, so I can indicate my east. All right, this should be west, I believe, and this should be your south. So you can choose to indicate, you can also choose to do without it. So I'm looking at a boat sails 3 kilometers on a direction north 60 degrees. So I know my direction is somewhere here. So now this is the whole thing is 90 degrees, so you have to be mindful of how you sketch. So I can have here, and I told you earlier on that directions, the angle is always formed with the north line or the south. So this will be my 60 degrees. And then if I end here, I have to bring my cardinal point because perhaps I might want to continue again. So that will guide me. So bring your cardinal point. So maybe this is my point, my end. So that can be my B. So now this is my starting point. The boat is now here. And the question we're asked to determine how far west is the boat. So the boat is here. So, you know, all this length talk about west, going west. So how far west? I have to make sure I get it accurate. So I'll pull down to know the length. So going here, I can now trace and see that, okay, the boot started here, and once the boot is here, when I pull down, this is the length the boot has covered westward. So this is what we are to find. Now, this shape looks like something that you know. This is a triangle, and this line, when they meet, the angle they form is 90 degrees. So this is a right triangle. And from our lesson on trigonometry, you should be able to go ahead and find the missing side. So we want here, I can then put X over here. We're given the distance as 3 kilometers. So once this angle was given at 60 degrees, then once you're interested in the missing side, we can locate the acute angle in the triangle. And here will be 30 degrees nicely. So with your idea, we know under trigonometry, we talk about two main relationships that is between the sides and angles of any Pythagoras, any right triangle. And the first one is the Pythagoras theorem, and the second one talk about the trig ratio. So here, realize that with the information given to us, we will resort to the use of the trig ratio. So let's look at what we have. If this is 90 degrees, then here happens to be our hypotenuse, which is 3 kilometers. This side, these are opposite, but we are interested in the adjacent. So I'll start thinking about which of the trig ratios will relate my adjacent and the hypotenuse, and that is using our SOHCAHTOA, that's the cos. So I write cos. So our SOHCAHTOA. So this acronym that I could use to, so if I'm talking about cos, then cos should relate the adjacent and the hypotenuse. So I can now talk about cos 30 degrees, and cos is the ratio of adjacent, which is the x, to that of the hypotenuse, which is 3. So this is a typical equation that you can consider to make as a subject. So I can have 3 cos 30 degrees should be equal to our x. Yeah, so with your calculator, once I manage to input this, that should give me the value of our x. And if you do that correctly, you should get something around x should give us approximately 2.6 kilometers. So I decided to do 1 decimal place, but in a typical question, we're given the number of decimal places to approximate to. So it means that the shape is now 2.6 kilometers westward, right, from the starting point. Yeah, so that's a typical application of a question involving direction. Great, so I'll advise you try the second assignment on that. Let me start sharing my video, my screen. All right, so the same way in your groups, try to get it sketched. A ship sails 4 kilometers due east. So have your cardinal point. This is going east, going west, going north, going south. So I can work on this line. It's not done to scale, so you can pause anywhere and have your other cardinal point. So that should be the 4. Then that means that you are now here. So now here, your cardinal point is here. Going north, going east, going west, going south. So I'll go down and make sure that this line is longer than the other one. So that is 5. So you can stop there. Then you can connect the starting and the end. Now you find the direction of the ship from the starting point. So I recommend you use the north something east or north something west, or south something east or south something west. So that's typically not giving a bearing angle, but in this case, we are making use of the direction, the north and the south with reference to the east and the west. So let's do this in our groups and we can share our ideas later. All right, so let's make progress. All right, so now I want to look at a typical question that involves a given bearing angle, not a one in the form of direction. So let's explore this example. The point P is 3 kilometers due east of the point Q. So the Q is the starting point. So typically when I come here, I'll have my cardinal point, my starting point. So when I'm going east, I'm going west, I'm going north, I'm going south. So the question indicated that I'm supposed to move 3, and it's not drawn to scale, so just a sketch. So I'm assuming that up to here is 3 kilometers. When I stop here, have another cardinal point, draw a cardinal point, your cross here, nicely. All right. So make sure when you get here, you indicate the P. Great. So if R is 4 kilometers due south of Q, so still go to Q, and at this point move south. So this is our Q. I'll now go south and it should be 4 kilometers. So just make sure it's longer than the 3, but just a sketch. So I have here. And when I end, indicate your cardinal points. So that is 4. Now, what are you asked to find? Find a bearing and a distance of P from R. So you have two things. We'll find a bearing of P from R, starting point. So go to R. So let's go to R quickly. Bearing. So I'll face north and I'll move clockwise until I get to the line that joins P. So this, once I'm here from R, I'll look north and move. So this is the angle, the bearing angle that we are interested in. And don't forget, this is a right triangle. And we can apply our knowledge on the two relationship, either the Pythagoras theorem or the three basic trig ratios. Okay, so here realize that once I'm finding angle, I'll look at which of the trig ratios will connect my opposites and my adjacent, and that should be tan. That should be tan. So tan theta should be the ratio of my opposite to that of my adjacent. So in an attempt to find the angle, I'll find the tan inverse, and that should give me 36.87 degrees. Now remember, bearing should be 3 degrees, so I have to approximate this to 2 digits, so that should be 37 degrees. Then I have to make sure I bring my preceding zero so that I can have the correct bearing angle. So that's our bearing. Now you can start thinking about the direction, the distance. This is the distance. So typically we are going to apply our Pythagoras theorem to be able to find the length or the distance between P and R. So that should be the square root of 4 square plus 3 square. As I take the square root, you should be getting something which should be 5 kilometers. All right, so I think we should be good by now. So let's explore more examples. All right, so this is a typical question that involves more than 2 points. So let's see how it goes. A ship sails 24 kilometers from port X. So port S should be my starting point. A ship sails 24 kilometers from port X due south to a port Y. So draw your cardinal point. We have a north, south, east, and west. Now at the center, decide to go south. So go down, go down, go down. So let's pull this up. All right, so you can see my diagram. You can decide to pull your own paper in, start seeing if your diagram is tandem with what I have over there. All right, so please be mindful of our starting point from X. So that's it. So here, I'll recommend you have your cardinal point here. So north, south, east, west. So you go down, you go down. So not known to scale, so you can stop anywhere and indicate that's your 24 kilometers. Great. So let's see what happens. Let's continue the question. It then says due is from port Y to port Z. So now you are here. When you are here, have your cardinal point. North, east, west, south. So we are asked to go east. So I'll go, we can stop anywhere and indicate that's your 7. But make sure this line is not longer than this. So make sure you are mindful of the length of the lines, even though it's not done to scale. All right, so if you end, you just have your other cardinal point and indicate that's your Z. Now let's see what the question is asking us to do. Find the position of the port X from Z. Yeah, so that's talk about the angle will help you to get a position. So from Z, so That's a starting point. So I'll go to Z. I have to face north and move clockwise because I'm trying to write in a bearing form. So this is 90, another 90, 180, another 90, 270 plus this angle. And the question is, how do you get this angle? Remember, this is a right triangle. So that's my hypotenuse, this is my opposites, and obviously this will be my adjacent. So I'm looking at which of the three equations will relate my opposite and my adjacent. That should be tan. So after exploring through all this, you get 74, and bearing is from north. So clockwise, so it will be 270 plus that, this angle, that should give us 344 degrees. So, and I want to talk about the position that the bearing angle and the distance. So 24 kilometers on a bearing of 344 degrees. At this time, I believe we are strongly getting along and we are working collaboratively in our groups. All right, so let me continue. So this example that I'll also recommend you try in your group. So we have about 3 points to explore. Let's take it one after the other. P, Q, and R are 3 buildings on a level ground. So that can be your book. Your book can be the plane or your ground. So imagine, don't start imagining ground. You can have your book as your ground. Q is 4 kilometers on a bearing of 040 degrees. So let me put my drawing. My starting point is from P. So P. So great. So I have my P here nicely. This is my north. I want to look at 40 degrees. So not on the scale. So over here is my 40. So extend the line and it can indicate your 4 kilometers. When you get to your point, that's Q because the starting is from P, but I'll end at Q. Then you indicate your cardinal point nicely. Great, let's continue reading. While R is 3 kilometers on a bearing of 130 degrees from Q. So please, from Q. In this case, Q is now our starting point. So I'll go to Q. This is my Q. And I want to locate 130. So I'm here. I have to face north, clockwise. So this is 90. So 90 plus what will give me 130. Start thinking about that. So 90 plus 40. So this should be 40. You have to indicate 40 here nicely. So this will be 90 plus. So this is 40. Indicated over here. So nicely. Then extend your line. Make sure this line is not longer than this line because this is 4 and this is 3. Be mindful of that. So I've been saying, if you lose a sketch, this is shorter than this very line. Great. When I get here, I'll indicate my cardinal point and I'll name the destination. That should be Z. Now we have to find them. So at this point, you can now connect the Z and the P. Find the position of port X from Z. Find the position of port. Let me pull my screen. Find the position of, all right, great. All right, calculate the distance and bearing of P from R, excuse me. So calculate the distance and bearing of P from R. So let's go to a diagram from R. So that's our reference point, R. Then I'll end at the P line from R. So this is my R. I'll go north. So this is 90, 90. Then this is the line that joins the P. So the bearing that I want is from here to this place. So already this is 180 degrees, no problem. We have to find the angle over here. All right, so with the concept of right triangle, we should be able to determine what are the shape over here. In the first place, determine whether it is right triangle before we can proceed. If not, we are not permitted to use our Pythagoras theorem and the basic trivial that are SOHCAHTOA. So let's check. Here was 130, that's 90 plus 40. So this is also a quadrant. So if he has 40, that's why I placed 50 here. Even though 50 wasn't given a question, but here was 40, so I have to place 50 here. Great. Now let's consider this angle too. It was given as 40. And you agree that this line and this line are parallel lines. So this serves as a transversal line. So you can see a Z-shaped form. So these two angles will alternate. So you can see me pulling and bringing 40 here. So now let's check. We can find an angle in a triangle. This is 50 plus 40. So once this angle is 90 degrees, it means that triangle PQR is right triangle. So once the angle here is 90 degrees, we can now go ahead and use either our Pythagoras theorem to find this missing length, and also use any of the trig ratios to find SOHCAHTOA, to find the missing angle. Great, so you can see me finding the missing length, that's the distance from P to R using the SOHCAHTOA, our Pythagoras theorem, I should say. And I end up having 5 kilometers. Now, to be able to find a bearing, it is very appropriate for you to find this missing angle in the triangle. Then that will help you to find the middle. Well, when I move from here all through to here, that's 360 degrees. So assuming I know these two angles, then minus 360, I should be able to find the bearing, the required bearing. That's all. There are other ways to explore that too, but this is what I end up doing in my slide. So typically, I'm now looking at which of the angles will connect opposite and adjacent, and that's tan. So exploring, going through that in your groups or individually, you should be able to determine that the angle over there should be 53 degrees approximately. Now, as I indicated, the whole angle is 360. So if I net out these two angles from 360, then what should remain should be the bearing angle. That should be the bearing angle. That's from north all the way to this place. That should be the bearing angle. All right, so I'm sure you have explored that and we are on the same page. All right, so this is an example that you might want to explore on your own individually to be able to monitor your progress. So it's pretty simple. Y is 25 kilometers from X on a bearing of 0.75. So basically have your cardinal point from X, starting point X. So the whole place is 90. So demarcate a place for 75 and have your line. You can stop anywhere and indicate your 25 kilometers. Name that destination as your Y. Determine the bearing of X from Y. So this is pretty simple, and I believe you are exploring it individually. All right, so this is another question that you might want to explore. It's similar to what we did earlier on. So a ship sails from port R on a bearing of 0.65 degrees to port X. So be mindful of the starting point from port R. So quickly, nicely over there, I have my starting point R. Then 65, not on the scale. From here to here is 90, so I just have to imagine 65 and extend my line. So this is 54 for me. When I end, destination is X. Now let's proceed. It then says on a bearing of 155 from port X. So starting point is now X. So let's go to a diagram. I'll now be here. I'll face north and move 155. So that's 90 plus what? So start imagining 90 plus 65. So this angle, place 65 here. So this whole thing, 90 plus 65 will give us 155. So the question is that what will be the remaining angle here? If you're 65, then place the remaining angle here because the whole place is 90 degrees. So place it here. And also be quick to know that these two lines are parallel and these are transversal lines. So this angle here and the angle here will alternate. So here should also be 65. Then when you are done, make sure you check the angle here, the sum. If it's 90 degrees, then you are good to go. We can resort to our Pythagoras theorem to find the side and also our SOHCAHTOA to find any missing angle. So I will leave you to explore that in your various groups. You have the solution here, but you can do that and later you can check on your own. So these are examples that I want you to try individually and your groups as well. So try all these in your groups and I'll take the feedback later. So thank you very much for your time, and I recommend you subscribe to my channel so that when I post a new video, you'll be the first to get an alert. Thank you very much, and I hope to see you in my next video.